there were a lot of crop circles that went 3D these last few years. This one here is called the wormhole. And if you put this part forward in your space, and this part, this edge and this edge forward, you can see how this is a 3D type picture. And in the keys, it talks about wormholes. Therefore, every part of the three-dimensional space is connected to every other part through the basic unit called the superelectron. The superelectron breaks down into more subtle units of space, which you call the electron and subelectron spaces. These are interconnected by these wormholes. These wormholes spiral through the framework of space at a time that is reserved as a training ground for soul advancement. So here's another picture, a drawing of it, to where you can see it's more 3D. And then they gave us double ones. And they gave us mirror image wormholes. And this one here has got 5 different entrances to it. In some ways, though, I thought this was more like either the Michelin Man or the Pillsbury Doughboy. And then they gave us this one here, finally, this year, on a wormhole. This is for the people that aren't quite there, or maybe they're drunk. They weave from side to side. See, so, I mean, these masters that are creating these crop circles really are funny. They like us to laugh. See, because when you get into these far enough, you find out that when you get up with your coffee in the morning, you might find rug circles. That's, I mean, that's how far it was going with me. I mean, it was just, you know. So another part of the geometry was the first crop circle of this year was this one here, and it had 7 lines in it. Say do, re, mi, fa, sol, la, ti, do. 7 sections. And so I started studying more about the number 7. Why do we have this number 7 being so important to us? I mean, 7 days of creation, 7 days of the week, 7 continents, 7 seas, 7 wonders of the world, 7 chakras, 7 seals, 7 colors in our rainbow, 7 virtues, vices, 7 sacraments, and of course 7 deadly sins. You know, all these things are all 7s. And, you know, even Vegas, right? 7s. Why do we have all these 7s? So our group in Sedona studies the Keys of Enoch material and other books that J.J. Hurtak has written over many years. And every other Sunday, the second and fourth Sundays, we meet, and anyone is welcome to come to our group. But we really have a group of super masters that have been studying this stuff for, like myself, for over 20 years or better. And this day, on this Sunday, we were studying a section from this part here, and it said that each gateway of the house of many mansions has its own unique pattern, and it follows a prearranged set function. So ours is a house of many mansions. It's one house, and we have a basic set function that we follow. The prime generations of the 7 eons, or the mathematics of the overself, superimposed upon the tree of life, or the 7 seals, are the 7 chakras, the 7 axis of symmetry of the divine overself, united with the 3 fourth dimensional universes change. Here we must understand that 7 possible axes of the truncated tetrahedral model, known as the tetrachedecahedron, which is a truncated octahedron model. This model produces 7 unique pairs of parallel faces which are perpendicular to the respective centers, generating 7 axes of symmetry or spin. So this is how we looked after that. And it doesn't want to go to the next picture because it went up here, huh? Resume slides though. All right. No. This is how everybody felt in the class, because nobody understood that sentence. And they said, Fred, you're the one with all the geometry. What is this? So I went ahead, and the next class, I brought along my model, which turned out to be the truncated tetrachedecahedron, meaning 4, this is Greek, 4 is tetra, chi is an, deca is 10. And all these are hedron families, which is the mess of these 3-dimensional objects. So this was the object that he was talking about. It has 14 faces, 14 sides. But actually, what I found it really was it was really an octahedron. And the octahedron, if we take the points off of it, which is truncating it, so I made this model, and I could take all the points off, and I had the same thing. So that's all they did to create this model, was take the points off. And it was really funny. I was making these models with the points that come off. I had this dream. It was a real short dream when you wake up just right at that point. And it was this little kid. He was sitting there playing with blocks. And I looked closer and I found it was me. And here I am 60 years later playing with blocks. You know, it's just amazing how they do this to you. You know. So anyway, they were talking about this object also. And we have to understand now, to go into the rest of this, what dimensions are. First of all, we have the first dimension, just a dot. The second dimension, we get a line, or the first thing we can draw is a triangle. Not a square, but a triangle. It's the first thing we can draw. So from that, we get a tetrahedron. A tetrahedron has 4 equal triangles. It's the simplest thing that we can make in this universe. That's the most important part to understand. The simplest thing we can draw is a triangle, and the first thing that can be made into matter in this universe is a tetrahedron. The pyramid has got 4 sides with a square bottom. The tetrahedron has got the same bottom as all the sides. That's the big difference between them. Now, this tetrahedron has, you might say, relatives or friends, and they're called Platonic solids because Aristotle and Plato were the ones that described them in their works. The tetrahedron has the 4 sides. The cube is a hexahedron, and it has 6 sides. The octahedron has 8 sides. It's like 2 pyramids stuck together. The next one is a dodecahedron, 12 sides, and it's all made of pentagons. And the last one is an icosahedron, and it has 20 sides. So there's only 5 objects that we can make in this universe with using the same piece and same angle over and over and over again. That's how simple our universe is. It's down to 5 objects. Now, of these 5 objects, the tetrahedron is very important because if we go ahead and truncate it, and I made a bigger one of those, so we're taking off the points, and we get the same thing, a tetrahedron, when we take the points off again. We go ahead and truncate it, and we get this, which is a truncated tetrahedron. So now we had to figure out how this had 7 ways to spin. It was fairly easy for me to figure out 4, going just from a big flat side to flat side. There were 4 ways to make it spin. The other 3 ways finally came to me when I looked at the edges. You can go from this edge to this edge. And so I made another model with the axis in it and the 7 colors of the rainbow. This one here. And no matter how you spin this, it's balanced. It's just totally amazing. It looks like it would be totally unbalanced, but it's a balanced object. And it's made by taking a truncated tetrahedron. And if you were to take this object, you could put this inside of it, and each one of these pegs would turn out to be on the 2 sides, whatever 2 sides you picked. So this object fits inside this object. And this is the octahedron, this is the tetrahedron. So this geometry all fits together. So I found that what else was important about 7 and all these 7s? If we divide 360 by 7, we get 51.5. The angle of the Great Pyramid was 51.5. So they were telling us something when they constructed the pyramid on the angle.